Greetings, class. This is Dr. York-Hammons again. I couldn't quite get finished with all the permutations combination examples in the previous video, so I'm going to work a few more that were giving people some trouble in the homework. I'd received some questions about. So I'm looking in the study plan for chapter 3, section 4. This is problem number 27, and I believe this was one that was on the homework. It says a golf course architect has 4 linden trees, 5 white birch trees, and 2 bald cypress trees to plant in a row along a fairway. How many ways can the landscaper plant these trees in a row, assuming the trees are evenly spaced? That's a total of, let's see, 4 and 5 is 9, and 2 is 11. Now, if he had had 11 different trees, distinctly different trees, we would have just done 11 factorial, and that would have given us all the different ways that the trees could be planted. But the problem is that we have 4 linden trees, and in this particular example, we're assuming there's no way to tell the difference between those 4 linden trees. They're identical. And when that happens, you actually have to reduce your total number of possibilities by the number of ways that those 4 linden trees could be placed, which would be 4 factorial. Now, I did a paper that I submitted to the news items on D2L, so if that's still a little confusing, you might want to go back over and read the example I did with letters. But at any rate, we have 4 and 5 is 9, 10, we have 11 trees total. So I'm going to go to data, and I'm going to go to compute an expression. And I have to build my expression. So since I have 11 trees, I would do my factorial, and I would have 11 for my factorial. Now you have to arrow out of that because you're going to divide. And you're going to divide by factorials for each of the different types of trees that we have repetitions of. So I'm going to put parentheses because I have 3 sets of factorials. The first one is for the 4 linden trees. So I'm going to have a factorial of 4. That's the linden trees that could be arranged in 4 factorial different ways, all indistinguishable. And then I arrow out of that parenthesis and put a times sign. And then I'm going to do factorials again for the 5 white birch trees. So that's going to be a factorial of 5. Those birch trees, there's 5 of them, indistinguishable. So there are 5 factorial ways they can be arranged, and we wouldn't be able to tell the difference. Then I'm going to arrow out, use my keyboard to arrow out, one more times sign, another factorial, but this is for the 2 bald cypress trees, so that will be a factorial of 2. Then I'm going to say, okay, that's got my entire expression that I need to calculate, and I'm going to call this 3.4.27 because that's the study plan problem, also the homework problem that we worked. So when I compute, I've added another column to the data table. It says there are 6,930 ways that he could plant those trees. Makes you wonder how they decide on one particular way, something that has to do with aesthetics, I'm sure. Let's check that answer just to be sure we're okay. Whew, fantastic. I'm a little relieved to tell you the truth. All right, let's look at the next question. So the next question has how many different 10-letter words, real or imaginary or nonsensical, could be formed from the following letters? W, S, B, P, I, X, S, P, O, O. Now, if they had just been 10 different letters, we could have done 10 factorial and we'd have been done. But the problem is that the letter S is repeated twice. The letter P is repeated twice, and the letter O appears twice. every time those letters repeat, there's no way to tell when you have this O compared to that O. And so we have to reduce that 10 factorial by factors for the number of repetitions for each letter that's repeated. So I go to Data, Compute Expression. I'm going to build my expression. And if I had had 10 totally different letters, I would have done factorial 10. I'm going to arrow out of that. But since I have repeated letters, I have to divide that by a set of factorials. So I put my parentheses up, and I'm going to do a factorial of 2 because there are 2 S's that are identical. So I do a factorial of 2, arrow outside that parentheses after the 2, and put a times sign. Then I'm going to do another factorial for the P's, and there are 2 P's. So I do another factorial of 2 because there are 2 P's that are identical. I'm going to arrow out of that parenthesis after that 2 right there, and then I'm going to multiply, and I'm going to do another factorial. And it just so happens that there are 2 O's. So I do another factorial of 2, and that is my expression that I have to calculate. So this factorial of 10, or 10 factorial, has been reduced or divided by factorials for each of the repeated letters S, P, and O. Now I'm going to call this 3.4.29 and compute, and it says, I'm going to hide that table, 453600. 453600. Now I didn't put a comma in there, but it will know that you mean 453,600. So let's check that answer. Good job. So we got the correct number of different types of words. Again, real or imaginary. Well, let's see if we've got another question that's somewhat similar. How many different simple random samples of size 5 can be obtained from a population whose size is 52? Well, it means we have 52 objects and we want them to be taken 5 at a time. It doesn't matter what order they're in. It's not like we're indicating that we're ordering them in any particular way. So this looks like it probably should be a combination. So I'm going to go back to Data, Compute, Expression. I'm going to build a combination of 52 objects. Then I'm going to arrow over, taken 5 at a time. And I'm going to do the column label 3.4.31 and compute. And it says, I'm going to hide the little table. It says there are 2598960. That's quite a few different samples. 2598960. That's 2,598,960,000. Let's see if it lets me get by without putting commas in. It liked it. So let me see if there's something that involves the division. I'm going to pause and be right back. I found another problem that has given students issues in the past, and it's this problem. It says a horse race has 14 entries and one person owns 4 of those horses. Assuming that there are no ties, what's the probability that those 4 horses finish first, second, third, and fourth, regardless of order? Now, in this problem, we want to find probability, which means we have to find how many ways that his 4 horses could finish first, second, third, and fourth, regardless of order, out of all the ways that all 14 horses could finish first, second, third, or fourth. If you think about it, this person that has the 4 horses, in order for them to finish first, second, third, or fourth, if I don't care which horse places in which order, there's only one way. He has 4 horses, and they win the first 4 places. So I know that my numerator for this probability is going to be a 1. The denominator is going to be the total number of ways that those 14 entries could be the first 4 places. Again, regardless of order. Since it's regardless of order, then we need to do a combination of 14 horses taken 4 at a time. So I'm going to go to Data, Compute, Expression. I'm going to build my expression, and I'm going to do a combination because, again, it's regardless of order. I have 14 entries in the race, and I want to see who does the first 4 places. So, again, this is just the total possible outcomes for the race. So that's going to be a pretty big title there. But there were 1,001 total possible ways, total possible outcomes for the horses for first, second, third, and fourth. Now, that's my denominator, the total possible. So I'm going to do one more calculation. I'm going to compute an expression. And I told you my numerator is 1 because I know there's only one way for that owner to have all 4 of his horses place, if I don't care what order they place in the race. And then I'm going to divide that by the total possible outcomes for that race, that 1,001 that I just calculated. So I'm going to say, okay, and that's going to be the answer to 3.4.41. So I'm going to click Compute, and I'll hide my table. And it says it's 0.000999900. But I only want 4 decimal places. So if I go back over here and I look, I have a 0, a 0, a 0, and a 9, a 0, 0, 0, and a 9. And then the next place over is a 9. Well, if I add 1 to this 9, it's going to make it a 1, 0 in the 3rd and 4th place. So if I round that, that's going to be 0.0010. Let's check that answer. And it liked it. So we did a good job. That's all I'm going to take time for. I realize it's been 12.5 minutes, and I certainly appreciate your patience. Please don't hesitate to email me, contact me, let me know which homework problems you're having issues with, and I'll do my best to give you some examples. I look forward to hearing from you for Chapter 4.